Hi everyone, Quiveen here from the comfort of my kitchen. I hope that some of you got to see the blue moon the evening before last. On the sunset of the 31st of May, we had our second full moon of the month, the blue moon. We are looking just a little bit ahead into June here, and so the moon is going to be just a little bit past full. Just to make sure we're looking at the sky in a realistic way, we'll turn the light pollution a little bit up, and this looks right. So the sky that we're seeing here is pretty much the midsummer sky, or at least the summer sky. We're certainly in summer now. We have our bright star Arcturus pretty much dead in the south as darkness kicks in here at almost 11:30, and darkness still hasn't fully kicked in. We still have that glow of sunset over in the northwest, and a little bit of that glow will stick with us all night long. We'll move forward just a little bit so the sky gets as dark as it's going to get. The moon is just about to rise here and bring a reasonable amount of light back into the sky. The moon is just past full. However, as mentioned in a recent video, the moon is going to be pretty low in the sky all night long. You can take a look at some of my recent videos to find out why. We want as dark a sky as we can get because we're going to be looking at distant objects, deep sky objects outside of our galaxy. We're going to be looking for another kind of galaxy, a kind of galaxy that our galaxy is not. We're looking for active galaxies. Often when we talk about active galaxies, we talk about active galactic nuclei. And as you can see here, there's a lot of them. There are a lot of active galaxies. Active galaxies are galaxies that have an active black hole in the center. When we talk about active galaxies, what we're really talking about is their black holes. And many of these galaxies are very distant from us. So this galaxy in particular, if we've got its redshift, I don't think we have its distance from the sun, but it would be light years and light years. It's a very, very distant object. Generally, we see galaxies that are active, that have active black holes. And when I say active black holes, I mean black holes that are actively taking something in. We'll get rid of the ground in the atmosphere here, so we don't have to worry about looking at things that wouldn't be visible from our direction. Here is Centaurus A, or the Hamburger Galaxy, and you might be able to see why it's called the Hamburger Galaxy. It's got this kind of a burger in the middle with these two buns on either side. This is an active galaxy. So that means the black hole in the center of this galaxy, material is falling into it, and that material is generating jets coming from either end of the black hole. We can't really see the jets clearly here, but we are getting a better idea of the distance. Almost 16 million light years. So this is an incredibly distant galaxy from us. And of course, these galaxies that we see as very far away, millions of light years, that means we're looking millions of years into the past. And even on the scale of a galaxy, that many millions of years into the past makes quite a big difference. So I do want to see if I can find some other examples of galaxies that have a picture. Here we go, the Eye of Sauron. Quite apt name for this galaxy. It does look a little bit like an eye. It's an active galaxy, and you may remember from a previous video, this is a spiral galaxy that's not quite a normal spiral, not quite a barred spiral, and it has a little bit of a ring structure, a little bit of an ring around the actual center of the galaxy. So with this galaxy in particular, because we're looking down on the center of it, that means any material getting ejected from around its black hole is pointing roughly in our direction. This is only listed as an active galaxy, but active galaxies are often broken down into quasars and blazars, not just active galaxies. So let's see if any of these blazars have something like a normal name. They don't. These are all different catalogs, the new general catalog, the international catalog, different catalogs that keep track of galaxies. There are so many galaxies out there. Of course, not all of them have images that are loaded into Stellarium, and particularly these ones that don't have common names. Galaxies with common names seem to be more likely to be included in the various Stellarium catalogs and lists. So quasars and blazars are both different types of active galaxy. They both have jets of material streaming away from the black holes in their centers. The difference is where exactly they're pointed. Galaxies whose jets are pointed in our direction, pointed directly at us, those are blazars. The galaxies whose jets are almost pointed at us, not quite pointed at us, but pointed generally in our direction, those are quasars. So it doesn't look like we have quasar listed as an individual object. We only have bright quasars, and unfortunately none of them look particularly bright. None of them are coming up as images in Stellarium, but we do at least have some active galaxies that are coming up as visible, so hopefully we'll have a few more of those. Here's another galaxy that is millions of light years away, even further, 53 million light years away. And when the galaxies were younger, when the universe was younger, millions of years ago, there was more instability in the centers of galaxies. Galaxies were swallowing up more of their nearby dwarf galaxies. And as material falls into the center of a black hole, it gets accelerated. It ends up going very, very fast as it gets close to the center of a black hole. And this generates a lot of energy, it generates radiation. Some of the material that falls in towards a black hole doesn't actually fall all the way in towards the center. It gets accelerated out from the poles of the black hole. Those jets really are what tell us that the galaxy is active. And of course, the jets that come from the galaxies, they're often quite difficult to see. This galaxy, the Centaurus galaxy, does have jets coming away from the poles of its black hole, but they're not quite visible here in this image. The galactic jets are really what people want to study because they have material moving very, very fast, close to the speed of light, sometimes at the speed of light. Sometimes it at least seems like the material is moving faster than the speed of light, a superluminary motion. When these jets are pointed straight at us, we can get a better idea of how the jets are fluctuating, getting brighter and getting fainter, and how the jets behave as one end of the jet slows down and new material catches up behind it. So these galaxies are active galaxies. Here's another one, 53 million light years away. The galaxies that are active are producing jets. However, it is difficult to see the jets of the galaxy and the galaxy itself. Often the jets are a little bit fainter than the actual galaxy. So images that are pointed at the galaxy, images that are trying to capture the galaxy itself, they often don't capture the jets that are stretching away, which this galaxy would have. The Hamburger galaxy, it's another active galaxy. This is another Hamburger galaxy, so you can see it kind of has that patty in the middle and the bun around the sides. That patty is really lanes of dust and gas, dark lanes of dust and gas, similar to the darker parts of the Milky Way. When we look at the Milky Way, parts of it do look a little bit darker, and those are those rings of dust and gas. Here's the Helix galaxy or the Pancake galaxy. Again, it's a little bit fuzzy. We can't really see jets here. This looks like it might be an indication of jets, but because of the angle at which we're seeing this galaxy, it's very, very tough to tell. The jets that a galaxy produces are incredibly bright, full of energy, but they're still not always as bright as trillions of stars forming the galaxy itself. So we've got a few more here. Again, some of them are quite faint. The Markarian galaxies are, of course, all in a certain area. So, it looks like these ones are up by the Plough or the Big Dipper. Markarian's chain, of course, is close to, here we go, Markarian's chain. This is closer to the constellations Leo and Virgo. So some of these galaxies are no doubt active galaxies, but because of the way that Stellarium assigns labels, assigns pointers to these images of multiple galaxies. I'm not entirely sure, this just says galaxy rather than active galaxy, so I'm not entirely sure that this elliptical galaxy is the active one out of this chain. There's a good chance that it is actually one of the other galaxies that is the active galaxy. But active galaxies, here's one that looks quite interesting. It seems to be pretty distorted due to gravitational interaction with a neighbor probably. But active galaxies, they're galaxies whose black hole is actively taking in material and generating jets coming out of it. Those jets coming out of it are called quasars or blazars, depending on how they're pointing at the Earth. And by studying the material moving through those jets, people have an opportunity to learn about the black hole that created them and study material at really high energies, at really high velocities, things that would be, at the moment at least, impossible for us to recreate on Earth. So those are some active galaxies. I hope that you enjoyed taking a look at the ones that had images, and hopefully you have a better idea of what quasars and blazars really are. Of course, they have very interesting names, but what they really are the jets, or the black holes and the jets. Active galactic nuclei cause quasars and blazars, but quasars and blazars are really just kinds of active galactic nuclei. But hopefully you have a better idea of what makes the different kinds different now. If you enjoyed this video, please do like it. If you like this kind of content, then please subscribe to my YouTube channel. And if you'd like to read this information written down, you can do so on my website, queevingscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.